All right, so let me show you what the project is. This will be kind of fun. We're through actually with our curriculum. So we're going to do just some project things for the next 2 weeks, this week and next week before finals. So I have put something in Buzz here. So I'll pull that up. All right, so if we get into Buzz and we go down to the bottom, I have something called Buffon's Needle Project, this problem. So here's the description, and here's where you submit it. So let's look at the description, show what I have here. All right, so for this, you use toothpicks, matchsticks, needles, whatever you have, whatever you can gather a few of, that are all the same length and about that size, something small. So they're all exactly the same. And it shows some like burnt matchsticks in that picture. Anything you have that you can just get a small bunch of them together. So what you do is you draw lines on paper the exact same length as your toothpick or whatever you're using there. So you make several lines on the paper, just like they show in the picture there. So then you gather all your toothpicks together in your hand, just a few inches, not very high, just a few inches above, and drop them. Okay, so you're going to drop the toothpicks, and then you're going to count how many of them are crossing one of the lines on the paper and how many are not. And you're going to keep, make a little table, keep track of it. And you're going to, each time you're going to calculate 2 times the total number you dropped divided by the number that are crossing the line. Okay, then you're going to drop them again, and you're going to add to the total. Don't just do a different drop. If you're dropping 10 of them at a time, your next one is a total of 20 now. You've dropped 20. How many of those 20 cross the line? And so you're going to keep a running total. So like if I have 5 of them, okay, I've dropped 5, 3 of them are on the line. Now I've dropped 10, and 7 of them have been on the line. Now I've dropped 15, and 9 of them have been on the line. I'm just going to keep a running total. And do that multiple times until you've dropped like 100 toothpicks. If you want to go bigger than 100, that's great. So if you've got 20 toothpicks, you only have to drop them 5 times to get 100, right? So it just depends on how many you can drop. And then you're going to do this calculation every time. So make like a table or something. Make a table, total dropped, number crossing the line, and then this calculation. 2 times the number dropped divided by the number crossing the line. So if you drop 10 and 4 of them are crossing the line, it'd be 2 times 10 divided by 4. So you'd have your number would be 5 for that calculation. And then you'd drop again and you'd add. Now I've dropped 20 and 11 of them have been on the line. So 2 times 20 divided by 11. And you keep doing that. And then let me go to the submission page. So you go to the next over here where you turn in your data. So report your data and just give your best guess on what's happening. Is there a pattern? And this is something I'm testing because I've seen claims that there is a pattern that you will see. Like, are your calculations getting closer to any particular number as your total increases? When you've dropped 50 of them, is your number getting more and more refined? If you've dropped 100, is the number getting closer and closer to the exact same number every time? Or does it actually get close to any particular number, or is it really random? Because you think it should be random. Every time you calculate it, even though it's a growing number, now I've dropped 80 of them, but still it should just kind of be random. But the more you drop, the closer it should be to about the same percentage. You'd expect it to be a similar percentage. The more you drop, the closer it should be to the same percentage. So that's what your assignment is this week. Just a random math project here, not learn anything new, give you something like a math lab type thing to do here. And then we'll talk about this next Monday. So we're not going to do anything crazy these last 2 weeks. I just want to do some nice fun little math things just to play with some of that and just see what we can figure out, see what we learn. We'll be like math scientists here and play around with some of that.
Mr. Brock.
Yeah, go ahead.
I have a question. Because, how are we supposed to, draw the lines? Do we draw the lines randomly?
Well, they should be parallel to each other. And they should be exactly the same length as your toothpick. right? So
But
you
like
draw,
you can like separate them, like they don't have like, I don't know if I'm making sense, but like
okay,
if you put them on a paper,
right? You put them on paper, so you get
then you just go like straight up and down.
right. You can do it up and down or left or right, however you want to do it. Now this one, the picture there, they used graph paper to make it easy on themselves. You don't have to use graph paper as long as you draw straight lines.
Yeah.
But put one towards the top of the page and then measure out the length of your toothpick and put another line parallel to the first one that the exact distance away is the same as the length of your toothpick.
So like always like the same distance away and all that stuff.
Exactly.
Like,
The same distance. Every line should be the same distance. You look at their graph paper, they just counted boxes that equaled the length of their little matchsticks there. And
okay.
so it's the same length every single time.
Okay.
So that way, it could land in between the lines and not really touch if it's just a little bit diagonal. But if it was totally straight, it would be right between the lines perfectly. So this is called Buffon's needle. It's some famous problem from the 1800s. They sort of come up with this.
And it doesn't matter like how, I mean, like you have to put everyone like the same length apart, but it doesn't matter like if you choose for them to be 5 inches apart or like 1 inch.
Well, they're supposed to be the length of whatever you're dropping.
Oh, okay.
They should be the length of whatever you're dropping. So if you're dropping a toothpick that's 2 inches long, your line should be 2 inches apart.
Oh, okay. Got it.
Does that make sense? So yeah. If you look at their picture, their matches look like about 10 blocks or 9 blocks on their graph paper. It's the exact same length of whatever they drop. So that's how far apart you're supposed to put your lines. So that's going to be based on what you're using. If you use sewing needles, if you use matchsticks, if you use toothpicks, that's going to determine the length between your lines. So that kind of keeps it consistent that way, because if we drew lines 10 inches apart, we'd hardly have any of them land on the lines. So we have to be consistent with whatever length of the item that you're dropping. And of course, the more of them you can drop at one time, the better, because we're trying to get at least 100 total dropped. So if you got a bunch of them, if you can drop 25 of them at a time, drop them 4 times and do all the counting and the math. All right. Well, great. Well, I won't keep you guys. Like I say, we're not going to learn anything new algebraically. We finished all of the curriculum. We did that by the time the seniors got done. So all's left is just the 3 of us in here now. And I just wanted to do some kind of fun stuff, just something a little different, just using some of our math skills and see what we can learn. All right.